For years, AI video generation looked impressive in short bursts, but it was fundamentally unreliable for professional workflows. But recent developments suggest we have finally crossed a critical threshold, moving from experimental novelties to genuine production tools. In this intelligence briefing, we analyze the structural changes in generative models that are making realistic video possible. We'll explore why cinematic quality is no longer just a possibility, but an imminent reality for the global media industry. From architectural shifts to economic implications, the landscape of visual production is undergoing its most significant transformation yet. But to understand where we are going, we must first examine the deep flaws that plagued early attempts. Early AI video was defined by instability. Motion wasn't fluid, it was a series of hallucinatory transitions that broke immersion. Physics were inconsistent. A cup might turn into a cat, or a person's features might shift wildly between frames. This was the era of dreamlike AI. The core issue was a lack of world knowledge. The models didn't understand that solid objects shouldn't melt, or that gravity should be constant. Temporal coherence was nearly non-existent. The model would forget what it generated just 3 frames earlier, leading to constant flickering. Generation windows were also incredibly short, often limited to just 2 or 3 seconds before the entire scene would collapse into noise. For professional production, this meant AI was a novelty, something to use for aesthetic glitches, but never for primary storytelling. The barrier between AI and reality seemed insurmountable, but a shift in architecture was being quietly engineered behind the scenes. This era of instability served as the foundation for the next leap, as researchers identified the specific flaws in temporal modeling. The goal became clear. AI needed to understand the world in 4 dimensions, 3 of space and 1 of time. This sets the stage for the massive technical breakthroughs we've witnessed in the last 18 months. This is where everything changed. The breakthrough came from a fundamental shift in how these models process time, moving toward far stronger temporal consistency. Instead of predicting pixels, the new model started predicting motion vectors and physical volumes across multiple seconds of time. Architectures like diffusion transformers, or DIT, allowed models to handle much larger datasets and longer sequences with high fidelity. This enabled the models to maintain the identity of characters and environments, ensuring a person wouldn't change their clothes or face mid-scene. Simultaneously, we saw an improvement in deep prompt understanding. The models finally began to grasp nuanced artistic and cinematic directions. You could now specify lighting, camera angles, and specific character movements, and the AI would execute them with surprising accuracy. This shift into latent space optimization meant that the heavy lifting was done before a single pixel was even rendered. By compressing the video into a lower dimensional space, the models could generate more content with less computational overhead. This also led to a massive jump in resolution. We went from blurry 360p clips to crisp, production-ready 4K cinematic assets in months. The visual fidelity now matches the standards of professional broadcast and high-end digital marketing. Frame rates also stabilized, with native generation at 24 or 30 frames per second, eliminating the stutter of earlier models. This fluid motion is the hallmark of the new era. It is the definitive sign that AI is no longer just guessing, it is simulating. We are moving toward world simulators, models that can predict how light, physics, and people should behave in any given scenario. This is more than just video. It is a new way to interact with digital reality, where the only limit is the prompt itself. Now that we understand the technical how, let's look at the major platforms that are bringing these tools to the world. Google Veo is one of the most significant players, focusing on high-quality cinematic video and long-form consistency. Veo's strength lies in its ability to maintain environmental details across extended durations, a key requirement for narrative filmmaking. It provides directors with granular control over camera movements, such as pans, tilts, and dollies, making it a true digital camera. This level of control is what makes it a production-ready tool, capable of being integrated into existing film workflows. Then we have the Sora-style models from OpenAI, which focuses on simulating complex environments and realistic object interactions. These systems simulate the physical world with incredible precision, allowing for dynamic movements and interactions that feel grounded. Sora isn't just about video, it's about building a model that understands the physical laws of our reality and can apply them to digital scenes. This leads to scenes that are indistinguishable from reality, especially when it comes to complex lighting and material interactions. Runway Gen 3 remains one of the most accessible and widely used tools for creators, offering high fidelity and rapid generation. Runway's ecosystem is built for creators, with a suite of tools that allow for everything from text to video to detailed character editing. The level of precision in Gen 3 is unmatched in the consumer space. giving users control over motion, style, and camera paths. This has democratized high-end visual effects, allowing small teams to produce visuals that once required massive studios. Finally, ByteDance is developing scalable generative video systems specifically designed for social media and content workflows. ByteDance's approach is about scale, creating a system that can power global content ecosystems with high-quality, relevant video. This integration into social platforms will change how we consume and create content, making AI video a standard part of the digital experience. The impact on creators is profound. We are moving toward a world where the cost of visual production is no longer a barrier to entry. This doesn't mean fewer creators, it means more. It allows small teams to execute big visions without the need for massive budgets. The speed of the creative loop is also accelerating. You can iterate on a visual concept in minutes rather than weeks or months. This allows for more experimentation, more risks, and ultimately, more original storytelling. The tool is becoming an extension of the mind. We are seeing entirely new workflows emerge, where AI handles the technical execution while the human focuses on creative direction and narrative. This shift in labor means that the most valuable skill for the future creator isn't technical proficiency, it's vision and taste. We are witnessing the democratization of cinema. A person with a laptop can now produce visuals that rival a Hollywood studio. This is the end of the high-budget barrier. The era of the solo filmmaker producing cinematic epics is here. The traditional industry is already adapting, integrating these tools into post-production, pre-visualization, and even final rendering. This isn't a threat to the industry, it's an evolution. It's the next logical step in the history of visual storytelling. As we conclude this intelligence briefing, the message is clear. AI video generation is no longer an experimental novelty. It is moving into the infrastructure of media production. It is becoming the primary tool for how we visualize ideas and tell stories. For you, the creator, this means the ability to produce complex visual content faster and more efficiently than ever before. The speed of thought is finally becoming the speed of production. This is the AI feed. This is only the beginning. Stay informed.